Hi, Algebra 2. We're going to continue our talk about conics today, and we're going to focus on ellipses. So we started our talk the other day with circles, and know that we talked about there being only really three conics, the hyperbola, the parabola, and then the ellipse. And then a circle is a type of ellipse where its vertices are all the same, which would be your radius. Today we're going to go into more depth about ellipses. So I'm going to start our talk here with ellipses, and let's talk really quickly about some vocabulary terms. So here's our standard equation of our ellipse. And we'll talk about the differences here between which type of ellipse. So there's two types of ellipses, and one is where your major axis is on your horizontal plane, or your horizontal, where your vertex is horizontal, and then your co-vertex is vertical. And then there's another type of ellipse where your co-vertex is horizontal and your major vertex or major axis is vertical. So you can see that here. You have two different types of ellipses. One is where your major axis is horizontal, where you can see here, and then one where your major axis is vertical. So let's just take a look at the difference between these two equations, where your major axis is horizontal, and then the one where it is vertical. All right, so the horizontal looks like this: x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. And then your vertical, x minus h squared divided by b squared, and y minus k squared divided by a squared equals 1. Notice the similarities here. They're both, the numerators here of the terms are both written the same, right? You still have your x minus h and y minus k, x minus h, y minus k, where that h and k are still the center, right? Just like we talked about with circles. They both equal 1, okay? And then, but I want you to notice the difference here. With a horizontal, A is considered your major axis length, right? So major axis length, you can kind of think about that as your radius, but really it's not considered a radius. It's that major axis length. So A tells you which way it's pointing, where your major axis is. So here, where A is under your x value, you can know that that A is the longest, right, length for your axis, and so it's going to be horizontal. So I'm going to write here that A is your major axis length, and B is your minor axis length. So depending on where your A is, that tells you in the equation what type of ellipse it is, whether it's a horizontal ellipse or a vertical, right? So let's go ahead and look at these. Did we talk about? Nope, we didn't talk about focus yet. So here's some more vocabulary. Here's our focus. And the focus of an ellipse, let's write this definition down. They are two distinct fixed points x, y, where the sum, trying to shorten it, the sum of the distances is constant. So we'll talk about this, and this will be very apparent when we do the pin and string method, because that sum or that distance is going to stay the same as you draw your ellipse around the focus. So you can see in our picture here where your focus is. When it's vertical, it's always on your major axis here. So when it's horizontal, it's on your horizontal axis. When it's vertical, it's on your vertical axis. So I'm going to write that too. Always on major axis. All right, let's look at our next one, our co-vertex. So your co-vertex is found on your minor axis. So this length B is going to tell you what your co-vertex is, and your vertex is on your major axis. So let's think about this really quickly. Looking at our points here, your vertex are these 2 points, so it's that distance A from your center, right? And then your co-vertex is your distance B from your center, okay? So I want to look back at your focus here, finding the C value here. Finding the focus is the same as using our Pythagorean theorem, right? So it's C squared equals A squared minus B squared, just a little bit different there. All right, so let's look at these. We're going to graph some of these ellipses. So let's just talk about what the center, the vertex, and the co-vertex and the focus are, okay? So we're going to look here, and I'm going to refer back to my standard form to find out what my center is. So that center is still HK. So in this case, my center is 1, 2. I want to find my vertex and co-vertex, right? So let's just write that down. Vertex is on the major axis, right? And the co-vertex is on the minor axis. So I'm going to look for the largest number. That's going to tell me, because think about that, your major axis is the farthest one away from your center, right? So my vertex here is 9, but the distance is 3. It's the square root. So I'm going to say A equals 3, and my co-vertex, remember co-vertex and vertex are points, so I haven't written those down yet. My co-vertex is my smaller number, so that's the B value, and that's 1. So I want to find out what my focus is, and I'm going to do that by plugging it into this formula that we just talked about. I know my A and I know my B, so I'm going to find C. So I know C squared equals A squared minus B squared. So if I plug that in, 3 squared minus 1 squared, 3 squared is 9, minus 1 is 8, so C squared is 8, therefore C is the square root of 8. Don't know if I gave myself enough room. Let's look at this on the coordinate plane, and looking at it on the coordinate plane is going to help us figure out what those points are. So here's my center, 1, 2, right here. Okay. And then my A value is 3. So I know that it's horizontal, right, because it's under the X. So I'm going to go horizontally 1, 2, 3 this way, 1, 2, 3 this way. So I can either take my center and add 3 and subtract 3 from my X value, or I can just look at my graph. That's 4, 2. And it's negative 2, 2. So take a look at your vertex. You have 2 points, right? One on either side. And then my co-vertex, I'm going to do the same thing, except I'm going to go up and down. So it's 1 up and it's down 1. So my vertex here, I can either take my Y value and add 1 and subtract 1, or I can take a look at my graph here. So it's going to be 1, 3, and 1, 1 are the points for my co-vertex. Now my focus is a little bit different because I have this funky square root, right? So I'm going to need to really figure out what that, where's my phone? Get my calculator out. So I have the square root of 8. So I want to know what that is. 8 and square root, we have 2.8. So I'm going to go to the right 2.8 and to the left 2.8, and I'm going to take that from my center, right, from my x value. So to the right 2.8 is 1 plus 2.8 is 3.8, 2, and 1 minus 2.8 is negative 1.8, 2. So know that for your center, you'll have 1 point. For your vertex, co-vertex, and focus, you'll have 2 points each. All right, now we can go ahead and draw our ellipse. Ta-da. All right, let's do the next one. I'm going to grab a different color pen. That way we can see it a little bit better. How about green? I'll do some green here. There's a lot of work on that one question, right? All right, actually, let's go to C. I'm going to let you do B. Let's go to C. I want to know my center, my vertex, my co-vertex, and my focus, right? So we'll go through the same process. I'm going to look at my equation here to tell me what my center is. It's negative 2, negative 2. Now my vertex, I'm going to look, okay, my biggest number is 16, so I know that it's going to be a vertically stretched ellipse. So I'm going to take the square root of 16. A is 4. And then my co-vertex is my x value here, so B is 2. Now I'm going to find my focus. So C squared equals A squared minus B squared. 4 squared minus 2 squared. That's 16 minus 4 is 12. So C equals the square root of 12. Well, we can simplify that, can't we? Or we can just, figure that out. All right, so let's see. I know now it's going to drive me crazy. How about 2 square roots of 3 for C? All right, so let's go ahead and plot our center. Negative 2, right? My vertex, remember it's under my y, so it's going to be vertical. So I'm going to be counting up, right? 1, 2, 3, 4. Oh, look at that, that's funny. 1, 2, 3, 4, down. All right, so what are these points? Let's see, you can either take your y value and add 4, or just count on here. So I have negative 2 plus 4, that's 2. And I have negative 2 minus 4 is negative 6. So there's my 2 points for my vertex. And now I want to look for my co-vertex. So I'm going to look for my value B, 1, 2, right? 1, 2. So I have my co-vertex. So I can either look at my points here on the graph, or I can count from my center. And I'm going to move my x value, right? So negative 2 plus 2 is 0. And negative 2 minus 2 is negative 4. All right, now my focus. I'm going to look here because I need an actual number, decimal. So it's we'll say 3.5. So I'm going to count both ways, 3.5, 1, 2, 3.5 this way, 1, 2, 3.5 this way. So there's your focus. So since it's up and down, it changes my y. So it's negative 2, and then negative 2 plus 3.5 is what, 1.5? And then negative 2 minus 3.5 is negative 5.5. All right. So we have all of the things that we need: center, vertex, co-vertex, and focus here. We can draw our ellipse. It kind of intersects with that other one. Very interesting. All right. So there's graphing ellipses based on the standard form. Now moving on to the other side, we're going to write the standard form of the equation of the ellipse with the following information, okay? So here we go. It says with vertices negative 2, 2. So this is example 2, and this is letter A. So we have vertices. That's on your major axis, right? 2, 2, and 4, 2. and we have our co-vertices of 1, 3, and 1, 1. All right, so let's think about this. I'm sorry, you can't see that. I want to think about this because my vertices, right? What is this telling us? Which number is changing? My x value is changing, right? So I know that it's going to be a horizontal. So I'm thinking about what my formula is here, my standard equation of my ellipse when it's horizontal, right? So when it's horizontal, your major axis length here is under your x value. So we could probably find our midpoint, remember midpoint, we could use our midpoint formula to figure out where that center is, because we know it's going to be smack dab in the middle of our vertex, right? So if we use our midpoint formula, x1 plus x2 divided by 2, and y1 plus y2 divided by 2, let's figure this out. -2 plus 4 divided by 2, and 2 plus 2 divided by 2. All right, -2 plus 4 is 2 divided by 2 is 1, and 2 plus 2 is 4 divided by 2 is 2. I like this math, right? Okay, let's bring it back. So this tells us what our center is. It tells us that our center is 1, 2. Now, what we also need to find are the lengths of A and B, right? So I need to know what is the length from the center to my to one of my vertices here and one of my co-vertices here. So a couple of different ways you can do that. You can just count, because I'm sure that you can just look at this and probably know. But we can also use the distance formula. So let's use the distance formula just so we can be mathematically correct. So my distance formula aren't you so happy that you paid attention in geometry? The distance is the square root of y2 minus y1 plus, or squared, plus x2 minus x1 squared. So let's take a look at this. I want to know the distance from the center to one of my vertices and the distance from my center to one of the co-vertices. So let's do to the vertex first. So we're going to say y2, 2 minus y1, 2 squared plus x2, 1 minus x1, positive 2 squared. All right, so let's see. My distance here is 0 squared, 0. And then 1 plus 2 is 3 squared is 9, right? So square root of 9, the distance there is 3. So I know that my major axis, A, is going to be 3, right? So let's do this again for this B value for our co-vertex. So I'm finding the distance from the center. I'll box this here so we can identify a little bit better. From my center to my co-vertex here, we're going to follow the same distance formula. So distance equals the square root. This is kind of messy, I apologize. Y value 2 minus 3 squared plus 1 minus 1 squared. 2 minus 3 is -1 squared is just 1, and then 1 minus 1 is 0. So I have the square root of 1, which is just 1, so your distance there is 1. So B is 1. Now we have all of our information. We have our center, and we have our vertex, the distance to our vertex and co-vertex, so we can write the equation. We have x minus 1 squared divided by 3 squared, which is 9, plus y minus 2 squared divided by b squared, which is 1, equals 1. Nice job. So that's your answer in the middle of all of the hopclob. I should work better next time. All right, I'm going to let you do letter B, and then we'll go to letter C. We're still writing the standard form of the equation, But I do want to emphasize that we'll be using our completing the square knowledge from last time. So here's letter C. Get this straightened away. We have 4x squared plus y squared minus 8x plus 6y plus 9. So thinking back to our standard form of our ellipse, I want to show you again what that looks like. It was x minus h squared plus y minus k squared. Now we don't know yet which vertex, right? It could be A or B, right? A or B squared, A or B squared. We don't know yet. That's kind of part of the fun here in discovering what that's going to look like. So let's reorganize this. 4x squared minus 8x plus y squared. Oh, I had a 0, didn't I? Plus 6y. And I'm going to put that 9 on the other side by subtracting. All right. Now, because I have this 4 out to the front, we're going to factor that out before we complete our square. That's minus 2x plus another number, plus y squared plus 6y plus the number we're adding, negative 9 plus blank plus blank. Remember, I like to add my blanks there so I know whatever I'm adding on this side, I got to add to the other side. All right, so we factored out, we practiced this with circles. Whatever you put here, you got to multiply by 4 before you add. So I'm going to do my b over 2. Negative 2 divided by 2 is negative 1 squared is 1. 1 times 4 is 4. And we'll do the same thing here, divided by 2 squared. So that would be 9. I'm going to add 9 on the other side. All right, this is looking kind of pretty, isn't it? So we have 4x minus 1 squared. I skipped a step there, and y plus 3 squared equals 4. So this is looking okay, except I have some extra things that I don't need. I need this value to be a 1. That's the most important thing. So how do I make a 4 into a 1? Well, I do that by dividing by 4. So I'm going to divide everything by 4 so that can be a 1, which this is great because those end up canceling and I get x minus 1 squared. And when they cancel, what happens to our denominator? Because I need it to have a number on the bottom. Well, it becomes 1, doesn't it? Plus y plus 3 squared divided by 4 equals 1. All right, we have standard equation of our ellipse. That looks really good. With our center at, and this is just extra, right? This is our center. Is at 1, negative 3. Our A value is 2, and it's vertical, isn't it? Vertically stretched, and our B value is 1. So that's just extra information there. All right, D looks a lot the same. You're going to run through it exactly the same way. When we get back together in class, we'll go over the B from the first example and then the B and D from our second example. See you soon.